Hello, thank you for watching this video. So on this video, we'll be doing question 3 of November 2023 question paper Physical Sciences paper 1. This is the projectile motion, right? So let's go. I'll read the statement and then answer the questions that follow. So let's go. They're saying a ball of mass half a kg is thrown vertically upwards from the top edge of a building, which is 15.3 meters high. They're saying the ball reaches the maximum height of 5.89 meters above the top of the building, right? The ball strikes the ground and bounces vertically upwards, reaching a maximum height P as shown in the diagram. Let me try to read this thing again. They're saying a ball of mass half a kg is thrown vertically upwards from the top edge of a building, which is 15.3 meters high. They're saying the ball reaches a maximum height of 5.89 meters above the top of the building. The ball strikes the ground and bounces vertically upwards, reaching a maximum height P as shown in the diagram. So we have this ball, which is half a meter, so half kg. The mass is 0.5 kg of this ball. We have this ball, here is it. It's half a kg. This ball of ours is thrown vertically upwards, right? Here is it. It's thrown vertically upwards and it reaches a maximum height of 5.89 above the building. So it moves from here to there is the maximum height, right? So let me do this again. So from here to here, because this is the same distance, so this here is the maximum height, right? The maximum height reached by the ball is 5.89 meters, right? So this is where the ball started, right? And this is where the point that it reached. So our ball changed position from here to there. Our ball changed position from this top here to that point. So this is where the ball starts, and that is where it finishes. It starts on top of the building here and finished and stopped or reached the maximum height at 5, which is what, 5.89 meters above where it started. So the ball is thrown from the top of the building, and the maximum height that it reached is 5.98 meters from where it started. So this is the initial position of the ball. That is the final position of the ball. Right? This is the initial position of the ball, and that is the final position of the ball. What is that? So our ball have changed position from here to there. It have changed positions from this point to that point over there. What is the change in position called? Because you know that it have changed position by 5.89 meters, because that's the maximum height it reached from the top of the building. So which means the change in position from here to here is 5.89. What is the change in position called? The change in position is called what? It's called the displacement. You call the change in position, which you calculate y is equal to y final minus y initial. It is the change in position. So the change in position from the rooftop to where it is this distance that is you have here. So you say final position minus initial position. What was the final position? Your initial position. You can say your initial position was 15.3, which is this one here, right? And the final position is 15.3 plus 5.89. That is your displacement. Because you will see how much this object have moved from its initial position. That is the displacement. So this 5.89 that you have there is the displacement. So you can find it by finding the initial height, which was 15.3, and the final height is 15.3 plus 5.89. You can do the calculations. It should come out at 5.89. So this part here, it is the change in position from the rooftop to the maximum height that was reached by the ball. No problem. So what are they saying now? They are saying ignore the effects of air friction. Define the term free fall. So they want you to define free fall. What is free fall? Free fall, it is the type of motion. It is a motion in which the only force influencing the motion is gravitational force. That's free fall. It's the motion in which the only force that is influencing that motion is gravitational force. It's the only force influencing the motion. Gravitational force, that is your free fall. I'm not sure if I have to write it down, but I can repeat it one more time. I'm not going to write it down. So free fall is the type of motion in which the only force influencing the motion is gravitational force, or gravity. Done. We'll move to the next one. Choose 3.2. What are they saying now? They are saying, using equations of motion, calculate the speed at which the ball was projected vertically upwards. So they want us to find this speed here, the initial speed of the ball. That's what they want us to find. Using the equations of motion. They want us to find the initial speed of what? Of the ball. The initial velocity of the ball. So, you know, if you throw something upwards, let's say I throw this, at some point it goes up and then it goes up and then returns. When you throw something upwards, when it goes up, its velocity decreases up to a point where it is zero, right? Then when it reaches that position of zero, that velocity of zero, and it cannot go up anymore, it returns by going down. So you throw it up, it will go up, and reach the velocity where it is zero, because as your object goes up, the velocity decreases, right? Because you know, if you throw something up, it will go up and come down. So as it is going up, its velocity or the speed gets smaller due to gravity, right? And it will get to a point where it is zero. Where it is zero, it will not go up, it will just sit there a bit and then come down. So what I'm trying to say is, at that point where the maximum height is, you should know that your velocity there is zero. So in our case, we know that it reached a maximum of 5.89, right? We should know that the final velocity there is zero at the maximum height, because it could not go up anymore. It went up and stopped, and then it will return after that. So at the maximum height, where the ball reached its highest point, or its maximum displacement, the velocity is zero there, because it could not go any further. It will just return, come down. So we have that we want the initial velocity, right? But we have the final velocity to be 0 meters per second, because we know at the maximum height the velocity is 0, because the ball cannot go up anymore. We have the displacement, which is what? So this is what I always do. The point where I started, I take it as 0 reference, right? All displacement above here for me are positive. All displacement below are negative. So, and also, I will take as my upward motion as positive. That's what I will do here. So I'll take my upward motion as positive. So everything above this point will have a positive displacement, and everything below here will have a negative displacement. So now my displacement is from this to that, so 5.89. It's above my starting point. So my displacement will be positive 5.89 meters. And your gravitational acceleration, g, is minus 9.8, because meters per second because I said that all my motion, upward motion is positive, my downward motion is negative. So should be my gravitational acceleration should be negative 9.8 meters per second So now these three are our known knowns, right? This is the known unknown. So let's find our unknown unknown using the equation, one of the equations of motion. That's what we should be doing. So how do we do this? Use the one that would work out. So for example, Vf squared is equal to Vi squared plus 2g delta y would work well. What is your Vf? Your Vf final velocity 0 squared is equal to Vi, which is what you're looking for. Initial velocity squared plus 2 into negative 9.8 times 5.89. So 0 is equal to Vi squared minus, get the product of that, 2 times 9.8, 5.89. So it's 115.44, right? Which means your 115.444 is equal to Vi squared, right? Then you take the square root of both sides, square root plus or minus square root of this. So your Vi is equal to plus or minus the square root of your answer, which is 10.74 meters per second, right? So because the initial velocity was going up and you said up is positive, so we'll leave this as positive. So that is your initial velocity. So it's positive because we said everything, all motion going up is positive and all motion going down are negative. But the initial velocity that we're looking for is going up, so it should be positive because up is positive. Done. Move to the next one. Okay, so now we're going to 3.3, right? They're saying after the collision with the ground, the ball leaves the ground at a speed of 11.92 meters per second. So when it hits the ground, it went up with a speed of positive 11.92 meters per second. So this was the bounce off velocity, right? No problem. They are saying now, calculate there. So what they're telling you, they're saying this ball was projected vertical upwards, went up, went down. When it got here, it bounced off at this speed here of 11.92 meters per second. It's positive because the bouncing speed is going upwards, right? So they're saying now, calculate the amount of kinetic energy lost by the ball after the collision with the ground. So they want us to find the amount of kinetic energy lost after the ball collided with the ground. That is what they want us to find. No problem. So what is the kinetic energy? What do they mean about kinetic energy lost, right? So when it got here, we need to find what was the kinetic energy this ball arrived with, right? The arrival kinetic energy in which the ball hit the ground with, and then calculate the kinetic energy in which the ball bounced off with, and see if there's a difference between the two, right? So after the, to find the kinetic energy, say EK is equal to half mv squared, right? No problem. That's the formula for your kinetic energy. So let's calculate the kinetic energy of the ball when it was bouncing off the ground, right? So the kinetic energy after bouncing, right, is equal to half the mass times the final square times the bouncing velocity. So kinetic energy when the ball was bouncing off is equal to half m times the velocity of the bounce, right? So your EK bounce is equal to half m. What is your mass? It was 0.5. What is your bouncing velocity? It's 11.92 all squared. So your EK for your bouncing is equal to the answer of this thing. So you get the kinetic energy of the ball as it was bouncing the ground. So 0.5 times 11.92 all squared. So your ball bounced off with 35.52 joules. So this is the kinetic energy of the ball. This is the bouncing kinetic energy. It was that. Then now, the question becomes, what was the kinetic energy of the ball on arrival, before the bounce? What was the kinetic energy before the bounce? So, EK before your bounce is equal to what? Half mv squared. What velocity is this? Is the velocity immediately before the ball bounced, before it hit the ground. So we need to find that velocity because we don't have that velocity. Right? So, how do we do this? We say, okay, what we know is, we know the initial velocity of the ball, right? Because we discovered that the initial velocity of the ball was 10.74 meters per second, right? We want the final velocity of the ball, and we know the displacement. The displacement, it is the change in position. So the ball started here, right? And at this point is a zero reference, this point. So this is where the ball started. And then it ended up there. So the change in position is this distance over here, from here to there. Is this length here, this length here. It's a change in position because the ball started there and it's sitting here now. So the displacement is what? The displacement is negative 15.3 because I said everything below here, all displacements below are negative. All displacements above are positive. And I said this one was positive. Look, even when I was doing my calculation, I made it positive because it is above my reference point. So, but this one, now when it hits the ground, it's hitting the ground 15.3 meters below where the ball started. So it will be negative because it's below the starting position. Right? So what do? We say now, your kinetic energy before the bounce is called O. But we can't calculate this kinetic energy because we need the final velocity. So we can say Vf squared equal to Vi squared plus 2g delta y. You want your final velocity there. So your Vf squared is equal to your Vi. What was your initial velocity? It was 10.74 all squared plus 2 times your gravitational acceleration. What is it? It's a negative 9.8 because it's downwards, times your displacement, which is your change in position. Your change in position, your displacement, is this from here to there. It's below the starting point, so it's negative 15.3. So here we have negative 15.3. So your Vf squared is equal to, punch that in your calculator and see what you get. So it's 10.74 all squared plus 2 into negative 9.8 times minus 15.3. So your square root of your velocity is 415.23. Take the square root, you take the square root. You get that you say plus or minus, of course, your velocity is equal to plus or minus the square root of that, which is 20.38 meters per second. Now the question becomes, should this be negative or positive? Is the velocity, final velocity is pointing downwards like this. So we said all velocity downwards are negative, so this should be negative. So here is your velocity for that. You get that the final velocity is is 20.38. No problem. So what we do next, we find our kinetic energy before bouncing, which is this kinetic energy. So you say your EK is equal to half m, which is 0.5. So V 20.38 all squared. You can make it negative. It won't make any difference because it's squared anyway. So your kinetic energy before bouncing, EK before bouncing, is equal to the answer to this thing. Use the quarter of. So 0.5 times 20.38 all squared. So you get that your kinetic energy before bouncing was 103.84 joules. This was the kinetic energy before it bounced, right? And then when it bounced off, it had that. After bouncing, the ball had this kinetic energy. The difference between the two is the kinetic energy lost. So the EK lost will be the difference between this and that, because it came with this kinetic energy and it bounced off with that one. Where did the other one go? It's the one that is lost. So it will be EK of the bounce minus EK before okay. Yeah. So EK loss will be EK. How much kinetic energy? So you say EK. It doesn't really matter what. So what you say? You say EK before your bounce, which is the bigger one, minus your EK bouncing. Right. So it will be 103.84 minus EK of the bounce, which is 35.52. So EK lost is equal to the difference between the two. So it's 103.84 minus 35.52. So the lost kinetic energy is 68.32 joules. So this is the amount of kinetic energy lost during the collision or during the bounce. Okay, so now we're left with this one, right? So 3.4. Let's go. What are they saying? They're saying the velocity time graph for the motion of the ball from its instant it was projected from the top edge of the building until the time it reaches point P below is shown. So let me try to read this again first. The velocity time graph for the motion of the ball from the instant it is projected upwards from the top edge of the building until it reaches point P is shown below. So this is the velocity time graph of this motion here, right? You can see this is the initial velocity where the ball is projected. This is 10.74 meters per second, right? This is the initial velocity, and then this is when it reached the maximum height here. This is when it was here, because you can see the velocity is 0, and I said at the top height this is where the velocity is 0. Vf here is equal to 0, so this is the maximum height, and here I'll say this is where it bounced off, because it is you can see the velocity was negative, which means it was going down. So you can see your velocity is less than 0, so it was heading downwards, right? And then all of a sudden it became positive, so which means this is the period of the bounce, this one, what you have here. So this is where it hit the ground and then it bounced off, and then now the velocity became positive because the ball is going upwards. Because you can see your velocity is positive again because the ball is going upwards, and as it is going upwards, this is the velocity it is going upwards with, and you can see the velocity is getting smaller, getting smaller, getting smaller until it is 0 there, which means it is going up until it reaches the maximum height. So this should be position P there. That's what the maximum height is. That's how we look at the velocity time graph. So if you look at it, this is where it's starting, which is projected vertical upwards, and the velocity getting smaller until it was 0, which was now it was going up until it reached the maximum height. This is the maximum height, the velocity is 0. And then from there, it returns going downwards up until it hit the surface, because this is where it hit the surface. Because immediately after this, it became positive, which means it was bouncing off the surface. Bounced off the surface with this velocity, which is this. And then the velocity decreases up until it became 0. Where? At P. Because at P, that's where it reached the maximum height. No problem. That's saying write down the numerical value of each of the following. 3.4.1. They want you to write down the numerical value of K. What is K? K is this velocity here, the bounce off velocity. Because, like I said, it was going down here, it was negative. All of a sudden, it became positive. It's the bounce off velocity, which was 11.92 meters per second. It's positive. Done. Go to the next one. 3.4.2. What are they saying? Write down the numerical value of L. Where is L? L is that. That is the initial velocity of the ball. The one it was projected with. It was projected with what? With 10.74 meters per second. That was the projected velocity, 3.43. What do? They want to find T2 minus T1. They want to find the difference from this time to this time. Right? They want to find the difference from this time, which is to this time over here. This is the time that they are looking for. So, I would say, this is the initial, so we can say now, they want the time it takes from here to get there, right? So you have your initial velocity, which is 11.92 meters per second, and you have your final velocity there, which is equal to 0. So you can find that time, right? You can say, okay, final velocity is equal to initial velocity plus g delta t. Your final velocity there at P is 0. Your initial velocity was 11.92 plus negative 9.8, which is g times delta t. So 9.8 delta t is equal to 11.92. So divide by 9.8 divided by 9.8. Get that the time is equal to the answer is 11.92 divided by 9.8. Which one should be positive? Yeah. 11.92 divided by 9.8, which is 1.22 seconds. So it's the time from the ground to the maximum height P. And you know that this initial velocity there was 11.92 and this final velocity there is 0. So the time is 11.22. Done with digital motion. I hope they do make sense to you as they do to me. Thank you for watching. Cheers.